Now we're going to do the Bn coefficient. I got that formula there from the back of the exam paper, and filling in t, 2 for t there, we get 2 over 2 here. 2 over 2 gives plus 1, minus 2 over 2, minus 1 here. And below the line here, instead of big T, we have 2. We're subbing in 2. So those guys are going to cancel off, and we'll have 1 minus 1 sine of n pi t dt. And that's not right actually, because I'm supposed to have t minus 1 in front of that, right? So just write it out a bit clearer. So we have 1 minus 1 t minus 1 of sine n pi t dt. Now we can split that into two integrals, so we'll have t multiplied by sine n pi t dt. Take away, we're multiplying the minus 1 by that, so we get sine in there, sine n pi t dt. Now there are some shortcuts we can take. We can get this guy here, and this is the type of shortcut you take no matter what type of these questions you're doing. You're always looking for these little shortcuts. Sine is odd. Why is sine odd? Well, when we did cosine, we got remember we did cosine and started up here, we got even. So for sine starts here and it goes like this, right? And sine is odd. It's symmetrical through the origin. Why is it? See, if it goes like this, you know, and if you turn the whole thing through 180, if you span the whole thing 180, you'd see that this would land exactly on top of this, so it's odd. And the integral of an odd function, as long as the limits are okay, the integral of an odd function always comes to 0. So this guy here all comes to 0, and that does take out a good bit of the work there. So we can rewrite our function, or rewrite our calculation, as it's just going to be the first bit there. T sine n pi t dt minus 0. So we forget about that minus 0 then. Gone. Now this is where it gets slightly tricky, and I'm looking at page 26 in the logbook here, and there's a rule here for this type of integration. And when you have this type of setup here, u dv, we're going to use this rule here. This is how you do it. U times v minus the integral of v du. Now u, we let u equal t, right? U equals t. So dv equals the rest of this structure. dv equals sine n pi t dt, and du equals dt. And to get v, we need v here, right? V is going to be the integral of this guy. We have to integrate him. So v is going to be, sine integrates to minus cos, so it's minus cos n pi t multiplied by the first derivative of what's inside the brackets. That's n pi. So that tidies up a bit to minus 1 over n pi times cos n pi t. So this is v here. This is the v we're going to use now when we construct when we're going to construct this guy here as our solution. So I'm just going to move down the page a wee bit. Now, so doing what's in the box here, uv, well, u is just going to be t, and v is this here, so it's going to be multiplied, the dot means multiplied by minus 1 over n pi times cos n pi t. That's our v. Now the limits will have to be applied to that. We'll keep our limits 1 and minus 1, and then we'll have our minus our integral, keeping our limits, and v, this is v still here, minus 1 over n pi times cos n pi t, and du is just dt, right? So where does that get us? So now I'm going to apply the limits here. T is 1, so we have 1 times, so the 1 doesn't make a difference. Oh no, I won't apply the limits actually. I'll, before applying the limits, I'll tidy up. I'll bring out this minus 1 over n pi, because that's constant, times t times cos n pi t. And we still have our limits. And we can integrate. No, we can take out this constant actually. You see the minus comes out here, and the two minuses give us a plus. So we have 1 over n pi times this integral of cos n pi t dt. Now we can apply limits here. So minus 1 over n pi, open the big bracket, and here that's going to be 1, that's going to be 1, so your first term is going to be cos n pi, minus the second term, we're going to have a minus 1 here, so we can stick it in there just to have the detail, cos n pi, and that's going to be times the minus 1, because t in the second instance there is minus 1. And I can start doing a bit of integration here, I guess. So cos integrates to positive sine, so we get sine n pi t times over the first derivative of what's in the brackets, that's going to be n pi, and I am going to keep the limits here to be applied later. So I'll just give myself a bit of space here, move that up. Now we'll still have our minus 1 over n pi on the outside. This is cos n pi, and the minus times the minus gives us a plus, so we've cos minus n pi here. That's going to be, there's going to be a little trick there in a minute. And over here, what are we going to do? We're going to apply our limits. Where are we? We are 1 over n pi. And oh yeah, well we know we're going to take out this n pi before we apply limits. See that's a constant that can come out, and it'll multiply by this guy, and you'll end up with this. So you'll still have your sine n pi t. Now, whatever question you're doing, a lot of these questions have similar bits to them, you know, a bit like Lego really. So now we're getting places. Now, if we look at page 13 on the logbook, you'll see that there's a rule there that says cos of minus a equals cos a. So we can get rid of this minus effectively, right? That'll be rewritten as, we can get rid of that. We get rid of that guy, so just turn them into a plus according to this rule here, right? So I'm going to end up with 2 of these guys. So I've minus 2 times cos n pi over n pi, and then I can look at my second part here, 1 over n pi squared. Now applying the limits, I'm going to have sine n pi minus sine, and that's going to be a minus there, so you're going to have n pi with a minus 1, so it's going to be minus n pi. As you can throw the minus, doesn't matter about the order of multiplication, right? And again, if we look up page 13, you'll see that there's a wee rule there that sine of minus something equals, this time equals minus goes to this type of format. So we can take the minus here and jump it out to here. See that? So we can, so effectively that becomes a plus. The minus comes out here and gets multiplied by this minus to make it a plus. Is that right? Yeah. So yeah, you're gonna have, well, I suppose I could stop you there and I could go back up to here and say the sign of any multiple of pi. You see, no matter what number goes in for t, from n equals 1 upwards, you're going to have sine 1 pi, sine 2 pi, sine 3 pi, right? So sine pi equals 0, sine 2 pi equals 0, and so on. So this guy here is always going to evaluate to 0. So we don't really have to go any further. You could tidy up this and you still come to the same idea, right? So we've landed with minus 2 cos n pi over n pi plus 0. So we're not too worried about the plus 0. So we've got as far as here. Now, so this is minus 2 cos n pi over n pi. Now, the value of this guy here, this little piece here, that depends on n. When n is 1, cos of 1 pi, see, this is a rough sketch of cos of 1 pi is minus 1, right? N is 1. And when n is 2, cos of 2 pi, see there, it's plus 1. N is 2. When n is 3, you can also put into the calculator, making sure the calculator is in radians mode. Again, you get minus 1. 3 pi down here, see it? Minus 1. So that goes on and on, right? So for n, cos n pi equals 1 when n is even, and cos n pi equals minus 1 when n is odd. Okay, so the value of this structure here varies between minus 2 over n pi and plus 2 over n pi. So when n is even, this guy turns into 1 and we get this. This is when n is even, n even. And this guy here then is when n is odd, because n starts at 1 and heads to infinity according to our Fourier series. So we figured out that b sub n is equal to minus 2 over n pi or plus 2 over n pi. Now it's equal to minus 2 over n pi when n is odd, and it's equal to 2 over n pi when n is even. So we've already figured out, in between this video and the last one, we figured out the coefficient a0, an, and bn. So for a0 we got minus 2. For an we got 0, so that's handy. We won't have to worry about all that bit. And for bn we got 2 over n pi, but that could be plus or minus depending on whether it's odd or even. Now in the next video I'm going to look, because I've only a 15-minute limit on these things, on the next video I'm going to look at putting these three coefficients together into the Fourier series. Now you'd already have a lot of marks got here before you'd finally polish it up and put them all into the series.